Hello everyone, I'm Mr. Amoyavi, one of your grade 12 advanced maths teachers. In our last lesson, we talked about tangents and normals and how we learned how to work out the equations of those two straight lines. In today's lesson, we'll talk about nature of stationary points. Nature of stationary points. Right, as you can see, I've got some diagram already that shows some points on a curve of y equals f of x. So we are going to calculate or determine the nature of turning points or stationary points. But what are stationary points? Stationary points are basically the points where the rate of change or the gradient will be zero, right? So as you can see on the graph here, at these points here, we have the dy over dx. dy over dx is basically the gradient function, which will be equal to 0. At this point here also, we have dy over dx is equal to 0. So basically, these are the points where the gradient will be equal to 0, and they are called the stationary points or stopping points. Right, so let's take a look at one example. If I have a function, okay, y is equal to 24 plus 3x squared minus x cubed. Right, in order to work out the turning points or the stationary points, we'll have to find the derivative of this function. So again, from the rule of differentiation we have learned, we can say the gradient of 24 is a constant, so it will be 0. The gradient of this part will be 6x minus 3 brought in front multiplied by -1. We have 3x squared. Okay, so what is this expression? It is the gradient function or rate of change function. Now, as I've indicated here, at the stationary points, the gradient here, the gradient of this curve here will be equal to 0, or it can be also equated to 0. So we are going to say the gradient at the stationary point will be 0, so the gradient is this function here, so we have to equate the function. 6x minus 3x squared equals 0. Right, why are we equating this to 0? Again, I've stated the gradient at the stationary points are 0. Right, so if I have to factorize this side, the common factor is 3 and x. Right, 3x is the common factor. 3x divide this one, it will be 2. 2 minus 3x divide this will be x is equal to 0. Right, by using the null factor law that you have learned in grade 11, that we have to equate each of the factors to 0 and solve for x. So here we'll have 3x is equal to 0, or 2 minus x will be equal to 0. Right, so for this part, x will be equal to 0. And for this part, if I have to bring this x over, x therefore will become 2. Right, what are these values here? They're actually the x coordinates of the turning points or the stationary points. Right, so in order to find the y coordinate of the turning point, remember a point is a coordinate, so it has to be xy coordinate. Therefore, if I were to find the y coordinate of the turning point when x is equal to 0, then I have to take this 0 and substitute in the original equation. Right, so when I substitute 0 for x in here, this will be 0, 0, and I will be left with 24. So y will be equal to 24. When x is equal to 2, or I take x equals 2 and substitute here, I will get 2 squared is 4 times 3 is 12 minus 2 cubed is 8. So 12 take away 8 is 4. 4 plus 24 is 28. Therefore, we will say these are the points, but we have to state it properly. Therefore, we will say the stationary points are 0.24, and the other is 2.28. Right. In order to determine whether this is a maximum, minimum, or this is a maximum or minimum turning points or stationary point, we have to determine the nature of the turning points. Okay. As you can see on the diagram, this side will be positive, this will be 0, this will be negative. Right? So if you get a shape that looks something like this, then it will be a maximum turning point. Or if you look at this point, I have a negative gradient, 0 gradient, positive gradient. So if you have a concave up shape like this, in terms of the signs, then this point here, the point that we calculate will be a minimum turning point. Now let's take, for example, this point. This is what we will do. We take the x coordinate of the first point here. X is 0. And then we are going to take some points greater than 1 and some value greater than less than 0. So I have 0 and also 0. A number greater than 1, rather 0. A number less than 0. Now we are going to determine the nature or sign of the gradient. Okay, if I have to take a number that is less than 0, let's say -1, and I take -1 and substitute in the gradient function. 6 times -1 is -6. 3 multiplied by -1 squared, that would be positive, so it would be like -9. So the value will be negative. If I have to substitute 0 in the same function, I get 0. If I have to substitute, let's say, +1, a number greater than 0. In this function, it will be 6. 6 take away 3, it will be a positive number. All right, so if I can create this small table here, you will find that we've got a negative, 0, and positive. So it will look something like this. We have a negative gradient on the left side of 0, and we have 0 and then positive. So positive, negative, and this will be 0. And this indicates to us that it resembles this part of the function. Therefore, in conclusion, we'll say negative, 0, and positive. So therefore, point 0.24 is the minimum turning point. Okay, before we conclude, you look at this point here. Since we have determined, or we have considered a cubic function here, we will have 2 turning points. Therefore, we got this point and this point. So the first one we have established is this one, the nature of it. So the nature of these turning points will be a minimum turning point. And this one, obviously, is going to be the maximum turning point. Right, so what we have actually learned is how we can determine the nature of the turning points by just using the idea of derivative. And we equate the gradient function to 0. We find the x-intercept, and then the y-intercept of the turning points, and then we use this small table here. We've used this table here to determine whether the number less than the x-coordinate is going to be negative, and then 0 and then positive. Or if it's going to be positive, 0 and negative, it will be a maximum turning point. All right, so that basically brings us to the end of this lesson, and I hope you have learned something. All right, so in our next lesson, we'll talk about the application for minima and maxima problems. Thank you, everyone.